Now it's time to get into the covariance. So, what's the difference between correlation and covariance? Why do we have correlation and covariance? Everything, all these questions will be answered in this video. So, covariance measures how much two variables change together. That's it, simple. Covariance measures how much two variables change together. When this variable x and y, for example, y and x, if x changes a certain amount, how much would y changes? That's it. That's what the covariance. So correlation is what's the relation between y and x. If x increases, y is decreasing or increasing. So the change is difference. Whether this change, whether the change is in positive way or negative way, but what we worried here is how much it changes. How much? So covariance measures how much two variables change together. So it indicates the direction, positive or negative, and magnitude of the linear relationship between the two variables. Okay. So that's what is covariance for us. Now, in another way, we can say covariance is a statistical term that refers to a systematic relationship between two random variables in which a change in the other reflects a change in one variable. So the covariance value can range from minus infinite to plus infinite, with a negative value indicating a negative relationship, a negative value indicating a negative relationship. Here a negative relationship means it's inversely proportional, and a positive value indicating a positive relationship, and positive relationship means positive, directly proportional. Then the greater this number, the more reliant the relationship. Positive covariance denotes a direct relationship and is represented by a positive number. A negative number, on the other hand, denotes a negative covariance, which indicates an inverse relationship between the two variables. Covariance is great for defining the type of relationship, but it's terrible for interpreting the magnitude. So let sigma of x and summation of x and summation of y be the expected values of the variables. The covariance formula can be represented as this. Covariance of x comma y, these are the two random variables x comma y. Now a summation of a product of summation of products of deviation, summation of product of deviation divided by n will give you the covariance. Okay, I'm repeating again. The product of the summation of the product of deviations of variable x and y will give you, divided by n will give you the covariance of x comma y. So here xi is equal to data value of x, yi is equals to data value of y, x bar is nothing but mean of x, and y bar is nothing but mean of y, and capital N is equal to number of data values, capital N or small n. The capital N is used for the population size and small n is used for the sample size, and this is what is a covariance for us.